Grade 10s, we have made it to the end of algebraic functions, and these are all the different functions that you need to have a good understanding of. So the straight line graph has got the equation y equals mx plus c. M tells us about the gradient, and c the y-intercept. The parabola, that's this one that has a curve. Y is equal to ax squared. Whenever you see a squared, that's when you must think of a parabola or a quadratic graph, plus q. In this instance, a tells us about the shape. So is it happy? Then it's a positive a value. Is it sad? Then it's a negative a value. And q over here is the y-intercept and the turning point. Then we learned about the hyperbola. And the hyperbola's equation is y is equal to a over x plus q. And the q value there represents what is known as an asymptote. So a line that the graph approaches but may never touch or never cross. The y-axis here is also an asymptote. So you'll see the graph gets very close to the axis, but it never intersects. The a value here also tells us a bit about the shape. If we've got a positive a value, our arms will be in quadrants 1 and 3. And if we've got a negative a value, then we'll draw in quadrants 2 and 4. And then the exponential graph, y is equal to a times b to the x plus q. When you see the x in the exponent, then you know you're dealing with an exponential graph. Okay, and that's one that grows quite rapidly. This a value will tell us if it occurs above or below its asymptote. The q value here is also the asymptote, just like it was in the hyperbola. And then the b value, if it's a whole number greater than 1, you'll see an increasing function. And if it's a fraction, somewhere between 0 and 1, then you'll see a decreasing function. Okay, so that was a very, very quick recap. If you want to know more about these, we do have separate videos on each of them, but the goal of this video is to actually combine these functions and to see what does this look like when it comes to us in a test or an exam, and how do we answer those questions. So here's our first example. Consider the graph below and answer the questions that follow, or answer the following questions. Okay, this graph here, just by looking at it, I can see that it's a parabola. I can see that it's happy, so this a value is going to be positive. The fact that there's a square here means it's definitely going to be quadratic. And this q value is going to be the y-intercept or the turning point. So I already know a couple of things, okay? Although I actually don't know enough about this equation to tell you specifics, but I can see this is definitely a parabola, and I've got some information here. Okay, the first question they say here is write down the coordinates of B. So what we need to do is we need to go and look at this graph that they've given us, identify B, and then ask ourselves, what is happening at this point? Is it an x-intercept? Is it a y-intercept? Or is it perhaps a turning point? Now in this instance, we can see, well, this is where the graph cuts the x-axis, so that makes it an x-intercept. Now what we should also know is that our axis here, our y-axis, is a line of symmetry, meaning that if this point C is the one intercept, then B is going to be the mirror image of that. So I can literally say, okay, well, I did 2 jumps from the axis to get to the point C. I'm going to do 2 jumps from the axis to get to the point B. And so nice and straightforward there. I can write down that the coordinates of B, and be careful there, they specifically want coordinates, so I need to give my answer in coordinate form. The coordinates there are -2 and 0. Then they say determine the equation of f. Now you might be tempted to say, well, here's the equation of f, and we're done, but there are too many unknowns. A and Q are missing from this equation. So we're going to need to determine this whole equation. Okay, we start by writing down the standard form. So you can write f of x equals ax squared plus q, but I'm going to write y, just because that helps us later when we substitute things in, just so we don't forget. So y is equal to ax squared plus q, and now I'm going to start and substitute some points in. Okay, I've got 2 points on this graph. I've got the point A and the point C, and I can substitute in either of those. Let's start by substituting in C because it's got a 0 there, and that's always nice to work with. So y is 0, x is now 2 plus q. Okay, so I look at my options and I go with the simpler one. This one has a fraction. I'm definitely going to save that for the end. Something with a 0 usually solves out quite nicely here. Okay, so what we end up with now is that 0 is equal to 2 times 2 is 4. So that's 4a plus q. And that's got two unknowns there. Do you see that? So we don't know a and we don't know q. We are now going to need to work towards getting another equation. So I'm straight away going to say, well, that's equation 1, because this is probably going to end up being simultaneous equations. Let's substitute in that other point then. So we know y is equal to ax squared plus q. And another point that we've got is 2.5 and minus 3. So a times minus 3 squared plus q. So 2.5 is equal to this minus 3 squared. So minus 3 times minus 3. A minus times a minus is a plus. 3 times 3 is 9. So 9a plus q. We don't know. And I am going to not quite call that equation 2 yet. Let's get one of these variables on its own. So if you have a look here, we've got 2.5, 9a, and then just a plain q. So I think that is going to be the easiest one to get on its own. Let's move this 9a across, and then we'll just have a q value that we can substitute in. So 2.5 minus 9a is equal to q, and I'm going to call that equation 2. Now what we want to do is we want to substitute, and in the place of q, in equation 1, we are going to write 2.5 minus 9a. Okay, so now let's write that down. We're going to say 2 into 1, just so we know what we're doing. And then we're going to say 0 is equal to 4a plus 2.5 minus 9a. Okay, now we can work out. This is just a simple equation. It only has one unknown, which is great. So we've got 4a minus 9a. That's going to give us minus 5a. And then I'm also going to take it over. So then it's going to become positive 5a. Okay, doing lots of steps in one. But you can check me if you want to do more steps and see that you come to the same answer. Okay, and then let's divide both sides by 5 so that we end up with just an a value. So a is equal to 2.5 divided by 5 gives us just a half there. All right, now we know what a is, and we can then find out what q is. So we're going to take this answer here, and we'll substitute that into that equation 2 that we were dealing with earlier. So now we can say, okay, well, q is equal to 2.5 minus 9 times, in the place of a half. Let's quickly calculate that. That gives us an answer of minus 2. And so now we know what the equation is there, and we can say, well, therefore, f of x, or y, is equal to, in the place of a half x squared, in the place of q, minus 2. There we go. We have determined the equation. Okay, that ended up being quite a lot of working out. But as long as you know what to do, you're okay. And the starting point is to write down the equation and then sub in what you know. All right, now they want the range of f. Okay, well, range, that's the y values that this graph is defined for. So I want to look at it and I can see, oh, here it goes all the way to positive infinity and then all the way down here to this turning point. So the good news is I've just worked out my equation and I can see that this turning point here is now cutting the y-axis at minus 2. And so now it becomes very easy for me to say, well, y is an element, minus 2 is the minimum value there, goes all the way up to infinity. Remember, it's allowed to exist at minus 2, so that's a square bracket, but we don't know what infinity is, so we have to put a round bracket there. Okay, let's take a look at this mixed example here. Determine the values of a, b, n, q, and t in the graphs sketched below. So what I'm seeing here is that I've got two graphs. I've got the graph of f, which is a hyperbola's equation. Do you see that? The minute I see there's an x in the denominator, I know it's a hyperbola. So that's going to belong here. I'm just going to color code because the sketch is quite busy. And then we've also got the graph of h, and h has got an x in the exponent, so that means it's an exponential graph. So h over there is an exponential graph. Okay, basically this whole thing here, all of these letters that they're looking for are variables in these two equations. Okay, so a and q, those are variables there in the hyperbolas equation, and bn and t belong to the exponential graph. All right, so all we actually need to do is just work out these equations, and then we'll be able to figure out what these values are. So I always start and I write down the equation. So a over x plus q, they don't always give this to us, so we're lucky in these examples today. But sometimes we need to remember the standard form and then start from there. Okay, what I know about these is that A tells me the shape, so I can straight away see this is going to be a negative, okay. But Q is the asymptote, and here's the asymptote, and it's so perfectly labeled, it's 1. So that's going to be the first thing I'm going to do, is substitute in the asymptote, so f of x is equal to a over x plus 1. And now I look for another point on my graph that I can substitute, and there's 1, 2, and 0. Be careful. Oh no, actually both of these points are on the blue graph here, so you could also go with 1 and minus 1, but like I said in the earlier example, zeros usually work out in the least complicated way. So let's use that point, and then if we need to, we can always come back and use the other point. So y, that's the same as f of x, right? So y is equal to 0. A over x is 2 plus 1. Okay, let's take this across. So it becomes minus a over 2 equals 1. And then let's multiply both sides here by minus 2, because then that will cancel with the minus also. And so we'll see that a is equal to minus 2. That's great. And then we want to, we've already got our q value. So we can say, okay, well, a is equal to minus 2. Q we substituted in, but seeing as though they've specifically asked us for it, let's say there q is equal to 1. So there we've answered their question. I also like to write it out. So I like to then say, okay, well, this here is f of x, which is equal to minus 2 over x plus 1. So my equation is now written down there. Right, now let's tackle that next one. So there we've got h of x is equal to n b to the x plus t. Okay, now these are not my usual letters. I'm used to a's and q's, but a variable is a variable for a reason, and that means it's interchangeable. So I just need to be a little bit smart, and I need to say, okay, although this is not the format that I recognize, t is still going to be the asymptote, and then these two are going to affect the shape and the slope of this function. Okay, so t I can substitute in straight away. So I'm going to say h of x is equal to n times b plus our t value there is 1. Hey, the asymptote is the same in both of these functions. Okay, now I'm looking for a point to substitute on this yellow graph. Okay, and believe it or not, I've got two options. So I've got 1 and minus 1, but if you look carefully here, 0 and 0 is also a point, and so we may need that. Okay, let's start with this one, because I'm 90% sure that's what most of you would have done. In the place of x, we put a 1. In the place of y, we put a minus 1. Let's see what we get. So minus 1 is equal to n times b to the 1 plus 1. Okay, now we're going to take that across. We're going to end up there with minus 2 equals n times b. Okay, to the power of 1, we can just leave. So there we still have too many unknowns. Okay, and the minute that happens, I don't panic. I just go and look for another point. So like I pointed out earlier, we've got this origin point here that we can substitute into. Okay, so we know the standard form of the equation, h of x is equal to n times b to the x plus 1 because of that asymptote. And now we can say 0 is equal to n times b to the power of 0 plus 1. Okay? Anything to the power of 0 is equal to 1. Be careful there, it doesn't become 0. Huh? So we get 0 is equal to n times 1, which is just n, plus 1. And then let's take that over. So we'll end up with n is equal to minus 1. And that helps me a lot because now I can take that and just sub that in there. Okay, so what I end up with, if I substitute in a minus 1 there, is that minus 2 is equal to minus 1b. And so b is equal to 2. And so there we've actually answered their question. There's the value of n, there's the value of b. And then t we didn't specifically write down, so let's say and t is equal to 1. And then just because it's very good practice, we can come over here and we can say, well, h of x then is equal to, now n we saw was minus, b we saw was 2 to the x plus 1. That's our equation there.